Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amirul Farhan and I'm gonna briefly explain about the methodology of this experiment. First, I'm gonna explain about the mercury. The Hertz tube is an evacuated glass cylinder containing a drop of mercury. The tube contains 3 electrodes, which is indirectly heated cathode, grid form anode, and collector electrode. The electrodes are arranged in plain parallel manner. The entire tube is housed in an oven enclosure. When the tube is heated in the oven, some of the mercury vaporized. After about 20 minutes, the temperature reaches equilibrium around 200 degrees Celsius. The hazy vapor pressure is now high enough that the mean free path of the electrons emitted by the cathode is smaller than the distance between cathode and anode. The retarding voltage is provided by a standard AA 1.5V battery. The accelerating voltage is provided by an ELWE Frank-Hertz operating unit. An electro industry's DC power supply is used to supply the current to heat the cathode so that electrons are emitted. A Heatley 610B electrometer is connected to the counter electrode to measure the electron current in the tube. The output terminals at the back of the electrometer, which provide a voltage that is proportional to detect current, are connected to a digital voltmeter. Data is collected manually by reading the accelerating voltage that correspond to each of the current peaks as observed by watching the electrometer. Now, for the neon part, the equipment used to study the electron-atom interactions in neon is similar to that is used for the Frank-Hertz in mercury experiment, except that an oven is not required and the Frank-Hertz operating unit is used to provide all the necessary voltage. The operating unit also contains a high-sensitivity DC amplifier for measuring the electron current at the counter electrode. Data is collected using a PASCO 550 computer interface. One input of the interface is used to collect the accelerating voltage data from the UB10 output of the Frank-Hertz operating unit, and the other input of the interface is used to collect electrometer current data. The operating unit provides output for displaying the Frank-Hertz signal on a dual-channel oscilloscope.
Result. This experiment demonstrates that quantum theory is real. Up to the experiment, the energy levels of an atom appeared to be an abstract idea. It verified the existence of energy levels in atoms like those of neon and mercury. According to the quantum theory, an atom's electron exists in distinct quantized states. During the experiment, it was noticed that the current abruptly reduced at a certain voltage, indicating change in the electron's energy. The overall display of these events on CRO revealed a number of bumps with varying current values. This made it easier to understand the quantized energy levels. This is the result of Frank-Hertz experiment.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Alisa Zuleka Binti Munir, and I'll be explaining the calculation involved in Frank-Hertz experiment. The first step, we gotta find the energy absorbed by an electron using the equation kinetic energy equal to negative electron multiplied by voltage. Second step, the value of contact potential was calculated using the formula G equal to U1 plus U2 minus differences of U2. Third step is calculate mean free path using the equation mean equal to KB T divided by SERT2 pi d squared P, which KB means Boltzmann's constant, T for temperature, D diameter of the mercury molecules, and P for pressure.